Okay, so we'll continue to discuss about the domain range in this video, and we'll be focused on the piecewise function. Alright, so what's the meaning for piecewise function? So basically, it is having different pieces of function, or maybe the different pieces of expression. Okay, when we're having the different number on maybe the different domain, I will say. Okay, so you can have a look for example 18, right? So like for part 1 and part 2, function here, generally they are having two different expression for different domain. Where x smaller than 0, we are taking the expression negative x squared. But when x is greater or equals to 0, so we are taking the function which is x plus 5. So this is what we call as piecewise function. Right, so if let's say in question, when we are having the piecewise function, to find out the domain and range, or to find out the range, I would say, basically the technique to decide the range, for me, I'm still using the sketching graph method. Alright, so by sketching graph, it will be easier for me to observe and determine the correct range for this particular function here. Right, so we discuss these two examples here. Maybe we discuss part 1 first. Okay, so for part 1, okay, for this particular function, we're having two parts, right? The first part is negative x squared for x smaller than 0. Another one will be x plus 5 for x greater equals to 0. Okay, so to determine the range, I will want to sketch the graph. Okay, so how am I going to sketch the graph basically? Okay, so maybe I label out the y and x axis first. So let's say this is my x and this is my y. And I will want to focus on this one first. How can I sketch negative x squared? So for negative x squared, right, original graph is x squared. And then negative x squared means that I want to reflect the original u-shape x squared become n shape, where my graph will look something like this. Okay, it should be a u-shape. It should be an n shape. Sorry, it should be an n shape for negative x squared. Okay, so this is negative x squared. But because for the domain given here, right, we only want the negative x squared when the domain is x smaller than 0. So where will be our x smaller than 0? So this part of the graph means x smaller than 0, which means that I only want to consider this part of the graph for the left hand side of the graph, because on the left hand side for this graph, it is happened during x smaller than 0. Okay, so that means in my real graph, I will draw a white circle here because there's no equal sign, right? X smaller than 0 without the equal sign. Therefore, I will draw a white circle here, and I only want to consider the n shape for the left hand side. Okay, so this is my negative x squared for x smaller than 0. Okay, after that, I will want to proceed to the graph where x is greater than 0. So for x greater equals to 0, I want to sketch x plus 5. Okay, so how can I sketch x plus 5? Okay, so again, maybe you can try to sketch x plus 5 by finding out the x and y intercept first. When y equals to 0, x equals to 5. So my x intercept is 5. Oh, sorry, when x equals to 0, y equals to 5. So my y intercept is 5. And then when y equals to 0, x is negative 5, right? So I will have negative 5 here. And this is my original graph. Alright, for the expression y plus 5. And because for this question, the expression x plus 5, we only want to focus on the domain x greater equals to 0. And where is the x greater equals to 0? This part of the graph is x greater or equals to 0. Therefore, when I want to sketch the diagram, I only want to consider this part of the graph, x greater equals to 0. So if I want to draw in my diagram, so this one should be a 5. Therefore, when I draw, it will be going up like this. Okay, so this part of the diagram is actually y equals to x plus 5, and the left hand side, the bottom part here is actually y equals to negative x squared. So this is what we call as piecewise function. We are having the two different expressions for a function, right, according to the different domain. Alright, okay, so after I sketch the diagram already, this is basically the piecewise function that I'm having for part number 1. And now I want to determine the range of fx. So to determine the range of fx, again, we are going to look for the lowest value, the smallest value for the diagram. So for this part of the graph will be going down, okay, to negative infinity. And then it will for the going up part, right, it will getting closer and closer to 0 here. Okay, but it will not, the value 0 is not included. So this is the first part of the range that I have. So for this part of range, when I want to write it out, it should be y smaller than 0 until infinity, right? There's no equal sign here because of in the domain, there's no equal sign as well for x smaller than 0. Then for the top part of the graph, I also want to determine the range. So from here, I can observe that the lowest point for this part of graph is actually y equals to 5, right? And the graph will keeps on going up. Therefore, the range for this part will be y greater equals to 5. So when you combine these two together, your final answer for the range for the function will be y smaller than 0 or y greater than 5, greater equals to 5. And for the 5 part here, you need to include the 5. You need to have the equal sign. Okay, so this is basically how we decide the range of function. Okay, especially this piecewise function from a graph. Okay, alright, so let's have a look for part number 2. Okay, for part number 2, again, you can see very clearly that I'm having two parts of graph. The first one is for x smaller equals to 1. The second one is for x greater than 1. For x smaller equals to 1, the expression is x squared minus 1. For x greater than 1, the expression is square root x minus 1. So how can we sketch the graph out, okay, for this particular curve? Okay, so maybe I focus on this one first. I want to sketch x squared minus 1. So to sketch x squared minus 1, the original graph is x squared, where it should be a U shape. And then when I have x squared minus 1, right, I have to shift the graph, the whole graph 1 unit down. When I try to shift the graph 1 unit down, it will look something like this. Okay, and this smallest value should be a 1. So it should be a negative 1. Okay, and if possible, I will want to find out the x-intercept as well. If I let y equals to 0, x squared minus 1 equals to 0. So from here, you know that your x-intercept is plus minus 1. So when I label my graph, I will know that my x-intercept is plus minus 1. Okay, then again, if I want to look at the diagram here, this function, they only consider x squared minus 1 when x is smaller equals to 1. So where's the graph that x is smaller equals to 1? This is the 1 basically. If they want to consider the graph that's smaller or equals to 1, that means they want to consider this part of graph. This is x smaller or equals to 1. Correct or not? Okay, so when you want to sketch this graph, it basically you only want to consider this part of the x squared minus 1. Alright, so again, if I label my diagram here, it will be something like this. Okay, so I will have maybe a U shape. Okay, then going up and stop here. So I will label this as 1. This one will be a negative 1, and this is also a negative 1. So this part of the graph is y equals to x squared minus 1. Okay, so after I settle the first part of this piecewise function, then now I want to go for the second part of the piecewise function. So I'm having x square root x minus 1. Okay, the original graph is actually square root x. So for square root x, basically it will be a graph something like this. Okay, where this is a 0. And when I'm having minus 1 inside the basic function, right? Okay, so when you're having minus 1 inside the basic function, basically you're having horizontal translation. Okay, so minus 1 inside the basic function means you have to shift your graph 1 unit to the right, according to the transformation concept that we learned earlier, right? Okay, so 1 unit to the right. So if I want to shift this 1 unit to the right hand side, that means your original point here is 0, 0, you will move become 1, 0. So this is my graph of square root x minus 1. Okay, so I want to bring it to my big diagram here. So you can, if you have a look, if you try to observe this part, this domain basically is already x greater than 1. So that means if I want to sketch this graph, it will be something like this. Okay, so where the green color part will be y equals to square root x minus 1. So this is how my piecewise function look like after I sketch the two part of the function. Okay, so after I sketch the graph already, then now I want to determine what is the range for this particular function here. Right, so again, to determine the range, you need to find out where's the lowest point, okay, for this whole graph. Okay, so the lowest point, you can see very clearly that it is actually y equals to -1. And then if you try to observe the curve also, this part, left-hand side, the graph keeps on going up until infinity. This part of the graph also keeps on going up, but at a slower pace. Right, so this one is increasing very fast. This one is still increasing, but the pace, or maybe the rate, is slower. All right, but no matter how, you can see very clearly that the lowest point here is equals to -1, and the highest point will go up to infinity, right? And therefore, if I want to write out the range for this particular piecewise function, it will be y greater equals to -1. Okay, so from here we can actually see that if we want to find out the domain and range, we are having a lot of different methods. Alright, so for me, usually I will just focus on using the graph method, okay, by combining all the transformation knowledge that we learned earlier. Okay, so we need to know what is the basic curve, what is the shape of the basic curve, and then how to apply the transformation on all the basic curve. And it will help us very, I think it will be very helpful. Okay, when we try to use all this knowledge to draw the curve or draw the graph, then use the graph to help us and decide the range. Alright, so this is what you have for the domain and range for the syllabus. Okay, so we'll stop here for this video, and next video we'll be discussing more about the composite function.